Hi there, I'm Rebecca Weaver. I'm going to be talking about adding and subtracting fractions today, maybe a little multiplication too. So let's visualize some fractions. I have two separate problems here. I have a couple of pieces of pie that I want to add together. And if I look at the first piece of pie, I can count the shaded blocks. I'm adding the shaded ones. And I say that I have 3 out of 8 pieces of this one pie. So I have 3 and it is cut into 8 slices. Next, I have 2 of these pieces of pie that are cut into 8s and I'd like to add them. And what I do is I will say that there are 5 total pieces out of 8. So that denominator is really out of, kind of telling me how the pie is cut, what it's out of. Let's look at the next pie. I have 1/3, and then I have 4/6. Well, I can't really say how many pieces I have because they're not cut in the same size slices. So if I were to try to add these, what I would need to do is cut up that pie. So if I cut it up so that it's in equal parts, and now it's in 6, I can say that I have 1/3 plus 4/6. And I now have 2 pieces out of 6 for that pie, plus 4 out of 6, and that equals 2 plus 4, which is 6 out of 6 pieces of pie. And if I add all of that together, I have one total piece of pie. One total pie. Not one piece, but one pie. So I have 6 pieces out of 6 pieces. So we have another little problem that we're going to look at. I like these ones that are visual. They're really cool. If A, B, and C are numbers where C is not equal to 0 because C is going to be our denominator here, so I can't have a pie that's not there because he's cut into no pieces. That doesn't even make sense. Where C is not 0, then A over C plus B over C equals, adding the numerators, A plus B all over C. And similarly, we can say the same thing for subtraction. A over C minus B over C is equal to subtract A minus B all over C. So let's look at this problem. Notice I have the same problem that I had previously, and I want to show how this fancy definition works for what we did. 3/8 plus 2/8 equals 3 plus 2 out of 8, which equals 5/8. So let's do some of these problems. I have 3 separate problems here for you. Now in the first one, what we need to do is keep that same denominator and just work the tops there. That -1 plus 3 all over 8 is going to equal 2 over 8. Now this one's going to need to be reduced. We're going to have to reduce that fraction by taking the 2 out of each. And 2 divided by 2 is 1, and 8 divided by 2 is 4. So this one equals 1/4. Now, of course, we're going to put some letters in there, so you have to really be able to add and subtract these fractions, not just with the calculator, because we're going to have letters in here, or variables. So x over 8 plus 2 over 8 equals, keep the same denominator, so it's all over 8, and then just add the tops, x plus 2. And you know what? I'm done, because x and 2 are not like terms. So let's look at a problem where we have 3 separate things going on. I need to follow order of operation. It's all addition / subtraction. So I'm just going to do this in order from left to right. So I'll do 5/8 minus 1/8, and then I'll do minus 1/2. So I just keep the same denominator. They're common denominators, and I'll just say the 8 goes in the bottom, and then 5 minus 1. And still tack on that minus 1/2. I'll then have 4/8 minus 1/2. Now I can choose to reduce that 4/8 to 1/2 because it does reduce. It has a 4 in each one of them. Or I could go ahead and get a common denominator and then reduce. Either way, it will work. But notice how cool this is because 4/8 reduces to 1/2, and I'll have 1/2 minus 1/2, which is then equal to 0. in adding and subtracting fractions, you need to remember common denominator. Now, it's convenient to use the least common denominator, but not required. I'm going to do the same problem. First, I'm going to use the least common denominator, and next, I'll just use a common denominator. So, in looking at -1/8 plus 5/12, I see that 8 and 12 have a common denominator of 24. What I'll need to do is multiply top and bottom of the -1/8 by 3 and multiply the top and bottom of 5/12 by 2. That will give me -3/24 plus 10/24. Then I just keep the same denominator and I would add the tops and I would get 7/24. In using a common denominator, I'm just going to use a big one. I'm going to use 8 times 12, and you'll see this is still going to work. It's just a little extra work, but it'll still be fine. If I didn't happen to see 24, I could have used 96. So for the first one, the -1/8, I'll multiply top and bottom by 12, plus for the 5/12, I'll multiply top and bottom by 8. What I'll end up with is -12 over 96 plus 40 over 96. I will keep the same denominator, adding the tops. -12 plus 40 is going to equal 28 over 96. Now this will reduce because each of those two contains a 4, and it reduces to 7/24. Now, if you didn't happen to see that, you'll remember in my previous video, I did show you how to use your calculator to reduce fractions, which is always handy. So let's visualize multiplication. I love multiplication. If A, B, C, and D are numbers where C and D are not equal to 0, when you multiply two fractions, you just buzz that sucker straight across. A over C times B over D equals AB over CD. So in my picture here, I have a square. It's divided into thirds, and I'm going to be looking at the white sections here, so the parts that aren't shaded. So I have 1/3, and I'm going to multiply it by 1/2. So I have one block, it's divided into thirds, and then I have another block, it's divided into halves. If I lay those two blocks on top of each other, what I'm looking to find is 1/2 of 1/3, basically. And when you lay those blocks on top of each other, you would see that what that is 1/6. So just buzzing that across, 1 times 1 over 3 times 2 is 1/6. So let's look at division. My rule for division, the mumbo jumbo, is if A, B, C, and D are numbers where B, C, and D are not equal to 0, then A over C divided by B over D equals A over C times the reciprocal, which would be D over B, and that equals AD over BC. So let's look at 2/3 divided by 1/6. So I want to know how many groups of 1/6 I have in 2/3. And so what I would end up with, trying to figure out how many 1/6 I have in 2/3, I would say 2/3 times 6 over 1, using that reciprocal. That's going to be 12 over 3. And that means that I will have 4 of those 1/6 in 2/3. Now, if I want to look at that, what that's going to look like is here, 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 and here. I have 4 of those 1/6 blocks. When I am looking at how many of those 1/6 blocks are in 2/3. All right, so when you're dividing fractions, just remember to flip and multiply. All right, let's do some problems working with fractions. I'm going to buzz these straight across. I can cancel on the front end if I want to, or I can just go ahead and buzz it straight across. Looks like somebody dropped a negative right there, so let's put it in there for them. -11 over 12 times 3x over 4 is going to be equal to -33x over 48. And that will reduce, because there is a 3 in both, to negative 11x over 16. My next problem, I'm going to be looking at some exponents. It's 2 raised to the third minus 3 raised to the second, all over 8. So I'll do some exponents and I'll do some dividing and some subtracting there. If you'll notice, first I did the exponents. 2 to the third is 8, minus 3 squared is 9. Performing that subtraction, I'll have negative 1 over 8. I can write it like this. This is a perfectly fine way to write it. Or if you like it better, it's negative out in front, because it just looks a little bit cooler when it's written as negative and then a 1/8. Notice this one here is a bit awkward, but it's still a correct answer, and there's no problem with it. But I prefer this one because this last one where it has a negative out in front and then 1 over 8, just because it looks so cool. In my next problem, I have subtraction and division. I'm going to do that division first. So I will flip and multiply that back fraction. I need to be sure and do this operation first. And I'll get 1 minus 2 over 40. And then I'll need a common denominator. So I'm going to have to write 1 as, I went ahead and reduced and then said I'm going to get a common denominator. That would be the fastest way to do it. So I'd have 20 over 20 minus 1 over 20. That's going to be 19 over 20. And that concludes a little reminder with some fraction work. You're going to be dealing with fractions from here on out. So a little practice in them will sure help you to be proficient with them. All right, if you have any questions or need any help, be sure and email me, rweaver10@alaska.edu. Thank y'all.